Hi guys, welcome back. So I'm printing out a new rotor. This is the top half, and here's the bottom half. So the rotor's going to sit like this with barrel magnets, north, south, north, south, north, south, north, south. So the coil will be underneath it as it spins like this. Look at that first layer. God, I love this printer. Anyway, let me get this thing printed out, put together, and we'll see what we will see. Stay tuned. All right, so as much as I like this rotor, the one that's really, really fast in this rig, I was too afraid that this PLA is not going to cut it. So I printed out a 3mm sleeve that'll go down over that, nice and tight. It'll go down over that, and that will definitely hold everything together, just like that. That will definitely work. So let me put this back inside here and give it a go. Stay tuned. Yeah, that sleeve will definitely hold it in because I don't think they'll come flying out this way. All the pressure is outward. Yeah. Runs nice and true. Love it. Nice and true. Let me get it hooked up. Yeah, now that I got that sleeve on there, ooh, that's putting out some really good power. Now that I got that sleeve on there, the hell is that? No, oh, I see what happened. Stay tuned. All right, now that I got that sleeve on there, I can put it up at high power because there's no way it's coming off of there now. But I need to put a bracket because it keeps sliding up. So I need to put a retaining bracket on the top there. All right, let me do that and bring you guys back. Stay tuned. Yeah, sorry about that weird interruption. I needed to put, they're calling it so, I think RD3DP calls it a rotor brake. I'm just calling it a support clip. I'm not sure what it's called, but it will keep the rotor on the shaft because it was sliding up. That's why I had to stop the video really quick. So let's there it goes. Really nice output. And that's 12 volts. So that's where I was afraid to do it before because I didn't think there was enough PLA on there. Ah, that thing is beautiful. It is screaming. I'm sure you guys can hear it. I'll be getting this guy on there next. Oh, yeah. Solid output. Yeah, I don't know if I even still trust it, even though it is screaming. I mean, I'm 99.9% sure it's not going to bust out, but there's always that 1% where I end up losing teeth. All right, stay tuned, guys. I think what I might do, because these magnets are so freaking powerful and so big, I might set up some more coils. Like I've got a bunch of these little coils here. I forgot what I made these for, but there's plenty of wire on there. I might set up a bunch of these. I think I have a couple of them that are on a platform. See how much power I can get off that. Or I may put these big guys in there. They won't fit. I'll have to put the spacers back on and maybe use these to generate the to generate the spin, the power for the spin versus pickup, and use these as pickup coils because these it's got really thick wire. It's got like, I think that's like 20 gauge wire, which will put out amps but not volt. I mean, it'll put out volts but not a lot. It'll put out more amperage. Where this, I believe, is 22 gauge wire, which is a good happy medium. It'll put out amps and volts. I mean, both of them will. You know what I mean. You know what I mean. Thicker the wire, the more amps. Thinner the wire, the more voltage. Yada yada yada. I don't know what this is. I think this is. I think that's like 23 gauge, 25 maybe. No, looks more like 22 or 23. Anyway, this guy's a beast. Um, I want to do some more experiments with this, especially now that I have this jacket on here. I'm 99% sure I'll be okay. Famous last words. All right, stay tuned, guys. All right, so I've got the new rotor in there, and it should hold really well. These are barrel magnets, so it's north, south, north, south. So it's north, south, north, south, north. I tried running it with the rotors um, upright and facing both the poles. It does work, but not very well. I only tried it with one of them. This is definitely the way to go, though, because of the way the poles are. So let me. Yeah, that's definitely the way to go. Really good output. And it's a maglev still. Probably get really good speed off of this too, even though it's not that close. Yeah, it's going a little bit too high. Let me turn it down a little bit. Turn it down to 7 volts. 7 volts is good. What I want to do is I want to get my D-shaped magnets underneath. My D-shaped rotors underneath. My D-shaped coils underneath there. Wow, 7 volts is really screaming. Let me turn it down a little bit. 6 volts. Yeah, solid output. Let me see how hot the resistors are getting. They're all right, but everything's all right. That's really good speed for 6 volts. Holy mackerel. That's because of this dual JL94 circuit. Let me turn it down a little bit more. There's 4 volts. Got a little bit of a knock. I don't know what that's from. It's nice and level. Nice and true. Oh, I think it's because I don't have all 4 of the screws in, but that's really good for 4 volts. Let's turn it down. There's 2.8 volts. I'm not getting any more output, obviously, because it's really low voltage in. Let me turn it back up to 4. So it'll stay going even if I turn it down 2.5 volts. That's really nice. All right, I got to get the D-shaped coil underneath there and try that out. Stay tuned. All right, so this has got, what has it got? 6 barrel magnets or cylinder magnets, and they're 3/4 inch tall. I had 4 of them left over that were longer, that were a full inch. So I couldn't use them in there. I wanted to make that an 8-pole rotor, and I could have used the 2 longer ones and just put them on the opposite sides, but I didn't want to deal with that. So I have these 4 longer ones, and I made this little guy here. And so these fit in there nice and snug. I'm going to put the other ones in there and test out this rotor. Stay tuned. So I lost some of the footage. I wanted to show you guys this thing apart. but I lost the footage. So I had some oddball magnets when I made this guy. Each of these barrel magnets or cylinder magnets are 3/4 of an inch long, and I had 4 of them that were an inch long. So I could have put them in here, and I could have put them on opposite ends, but I didn't want to do that. So I decided to 3D print out this little guy here, and it fits really, really well. And I've got screws so I can screw the thing together, and there's no way they're coming out of there. At least I hope they don't. Anyway, let me get that screwed up. I'll get it on there. I also made this guy here. I made this guy a while ago, but I added the screws to it so the magnets don't come flying out. And the other one, the other cylinder rotor that's really powerful, the smaller one with the 4 large rectangular magnets in it that are really powerful, I'm making a sleeve, a 3mm sleeve. I made the sleeve that went around it, but I'm making actually a cup with a top to fit around the whole thing. I'm 3D printing that now. You'll see what I mean when I show it to you. But let me get some screws in this guy and get him mounted. Stay tuned. You know, I was thinking I could put this guy up here and put a couple of coils up here and use those as a pickup. Use this as a, yeah, you use it as a pickup so I can use this guy, use these two to produce the rotation, and then use this with a couple of coils as a pickup to see how much power I can get out of it. But that's later on down the road. I was actually thinking about that with this guy here, and maybe using this as a trigger, so to speak, or using this as a trigger and getting that big, hefty cylinder rotor with the big rectangular magnets, because those are N52s. They're really strong. I could probably get a lot of pickup power off of that. Anyway, there's a lot of stuff I can do with this stand. This is a good stand. All right, stay tuned. So here's the sleeve I was talking about before that I made for that really hefty cylinder rotor with the larger magnets in it. I'm making another one of these, but with a sealed bottom and a sealed top. Actually, just the bottom will be sealed. I'll make the top piece separately and it'll fit down inside there. And I'll figure out some way to attach it. It's amazing that I can think of all these things to say perfectly when I'm not recording. And as soon as I turn on the camera, I get tongue-tied. You'd think I was like performing in front of 1 billion people. There's probably like 3 people that watch this. Anyway, that's what I was talking about before. This is still really good, but I'd have to create some kind of, oh, you know what I could have done? I could have just made 2 tops and 2 bottoms for this that overlap the top there. Yeah, I could have done that. I don't think it would have looked as good. I still might try to do that because I really like this one. Anyway, yeah, let me get this guy hooked up and we'll see what we'll see. Stay tuned. All right, so I've got this guy set up. I really have to develop a sliding system for these coils because I can't run it like this. I can, and at 6 volts, it screams. But I have to secure these coils down. And right now, the only way I can do that is with hot glue, which is not very good. I mean, it works, but then I have to use acetone, just a little sprinkle of acetone on there to get it off. But yeah, at 6 volts, it was screaming. So I'm waiting for my glue gun over here to heat up. I'll put a little tiny bead there and a little tiny bead here just to hold it in place until so I can do it. But I have to develop some kind of sliding mechanism. Something that it doesn't matter what type of coil I put in there, but I can just slide it in and out and lock it. And I mean, I can do that. I just have to get to doing it. So stay tuned. I keep losing the video. I'm not sure what's happening. Anyway, 5.5 volts. Moves really well for 5.5 volts. Solid output, not super high. Let's turn it up a little bit. There's 8 volts, and it's screaming at 8 volts. Let's turn it up a little bit. There's 10 volts. Yeah, that's a little bit too high for me. Again, I don't know how much I trust the PLA. You know what I'm thinking? Whenever I lose the video, it's when I bring this really close to it. I wonder if the magnetic field is messing with the camera or the phone and stopping the playback or the recording. Anyway, let's take a look at this. I mean, I think it would hold it okay. It's about 3 millimeters of PLA plastic. Maybe not. Anyway, I finished the outer housing for the really powerful rotor. I'm going to put that together and get it out here. And then I'm going to also put a reflective piece of reflective tape on it so I can get an RPM reading. Anyway, stay tuned. All right, guys, so here's that monster rotor. This is only at 3 volts, so there's no output. But yeah, this thing is a monster. I have to move these coils back. But I got to give it a rest for a while because my hand, I just had my hand looked at and they said I got to give this shit a rest. But I wanted to show you, let me turn it off. I wanted to show you what it looks like fully encased. Oops, I thought I turned it off. I did turn it off. This is what it looks like fully encased. So I should be able to get high speed out of this puppy. But that will have to be for another day. So thanks for watching.